these aren't, we weren't using this on the other one. We were using a whole. This is a decimal, so it's smaller.
Okay.
So we can use
Right, so these are representing your holes. I'm going to actually take a picture of this whole thing, if you don't mind, that you had out here. So once again, Colton was saying that these 6 sticks here represent what?
Put it on the side.
10.
They are 10 tenths. You're right about that. But in the problem, these 6 sticks represent what?
We don't need 10 of those. We just need 6. We're dividing by 6 holes.
These.
Look at our
Oh,
problem.
it represents your hole.
When our hole is how much? How many?
6.
6 feet. 1 foot. 2 feet. 3 feet. 4 feet. 5 feet. 6 feet. And we're trying to find out how many.
How many tens can go into all 6 tens?
That's exactly right. How many twos will get in there? So what do y'all think? What could you do? Keep
Wait,
working.
y'all gonna have to use these.
Do you even have to use them? Is there another way? Keep talking.
use
All
another
right, what's going on over here?
So we think we
Okay.
divide. So what we did was
Took 6 holes.
we divided 6 holes and we used it as a fraction basically.
Okay.
And we used 2 tenths as a fraction.
Okay.
And then 6 over 1 divided by 6 over 1 divided by 2 over 10.
Okay.
And then same thing flip. Then you could flip it and then it'd be 10 over 2. And then 6 over 1. And then 60 over 2, which would be equal to 30 holes because 2 times 30 equals 60.
Okay. So remember, part of our success criteria today was to be able to model and explain. You got about 30 seconds before we share. Okay. Maybe a minute. So you guys were definitely, I love your explanation of what you did, because you definitely were dividing 6 divided by 2 tenths. Because what were we trying to figure out? How many what?
How many
How many bows?
How many bows, but how big are the bows?
2 tenths.
Of a foot. So how many groups of 2 tenths are in
6 holes.
6 holes, which is what your division equation is asking, right? But part of our success criteria is to model that. So I hear the keep, change, flip kind of procedure, right? But what's the model look like for that? How could you show a model that shows there would be 30, and is it 30 holes or 30 something else? I'm gonna let y'all talk about that while I go disagree. All right, what's going on up here? What y'all come up with? What is this? Okay.
6 holes. 6 times 5 equals 30, so it's 30.
Could somebody write 6 times 5 equals 30 here so I can take a picture of that? So, did y'all hear what he said? Does everybody agree with you? Tell me your name, honey.
Eli.
Eli is saying 6 times 5 equals 30, but I don't see 30. I'm so confused. So what is happening here? What's the 5?
And the 5 is from all of these, so these are like 1, 2, 3, 4, 5.
So are they the number of groups or the size of the group? So the size is 2 tenths. How many groups did you make?
5.
5 in what? There's 5 groups in one.
In one.
One hole. Do y'all agree with that? In this one hole, there are 5 groups of 2 tenths. Would you agree with that? So then why? So the 5 is the number of groups in a hole. Why are you multiplying by 4?
If you do 5 plus 5 plus 5, so this would be 6 times. It will be 6 holes.
Okay. And so how many? The 6 represents what in the problem? 6 feet of ribbon, right? And we were trying to find out how many groups of 2 tenths would fit into all 6 of those, right? And so y'all were like, I'm not doing this for 6. So even did you have enough chips to do it for 6? You didn't have enough chips to show me 30 groups of 2 tenths, did you? So you showed me one and then used your thought, what you know about one to figure out what
2 tenths.
Yeah. I love it. Okay, so let's come back together. Let's do some share. Are you getting on it over here? Y'all figuring it out? No, it's 30. How many are in one? Remember how many are in one? 5. And then how many do you have? Think about that. Okay, so let's come back together. We're going to do a little share and look at the Elmo again at some solutions. So at this point, when we're sharing, no more messing with your manipulatives. No more drawing a model. Okay, you guys are doing some excellent thinking back there. I want to make sure everybody's on the same page. Are you ready? So remember, what we're learning today was to connect what we know about whole numbers to decimals. Are they the same? Are they? What do y'all think? Not really, but kind of? Well, so let's talk about how they're the same and different with our discussion, okay? So let's look at this first model, if I can find it. Hold on. First is this equation. Look at that. See that equation? 6 divided by 2/10? Yeah? So, like earlier, we had 6 divided by 2. And we talked about what that meant. So, I want you to talk to your group. What does this actually mean I'm doing? What does 6 divided by 2/10 actually mean that I'm looking for? Talk to your group. What am I looking for?
So if we were going to say we were going to use that, if we did that in this problem, we would use 6.
Okay, so come back with me. Just like when this was 6 divided by 2, we were trying to figure out how many groups of 2 would fit in 6, right? So when you were talking about this, what did you talk about at your table? What are you trying to find out here?
How many times can 2/10 go to 6?
How many times will 2/10 fit into 6, right? So let me ask you a question. Is this telling me the size of the group or the number of groups? Size. So in all of your models when I was walking around, you were making groups of the size of what? 2/10. And you're like, how many of these can I make? How many of these can I make? How many of these can I make? Right? So when we were solving this division problem, we knew that that fraction, and he wrote a fraction. Was it? I'm confused. Wait a minute. I thought it was 0.2.
Well, wait, decimals convert into fractions.
Decimals are fractions. They're the same thing, aren't they? So it's okay if we wrote the fraction here. So we were trying to figure out how many groups of 2/10 were in 6, right? So let's see if these other models help us make sense of that. So let me pull up this one and let you look at it. So look at this model. Wait, did I not take a picture of the blue model? I guess I didn't. Okay, let's look at this. I'll freeze it. All right, everybody looking at that? Remember what we know about what we were looking for? Remember, it was 6 divided by 2/10, what we're looking for? I need you to make sense of this model, because part of our success criteria was to model it and explain the model. So what do these things represent, and how did it help them solve the problem? Turn and talk to your neighbor. What's represented here, and how did it help? Yeah, so that's kind of what y'all were doing here, wasn't it? I forgot to come back to your picture of your blue and yellow and green model. I never took green. Okay, let's come back together. Look at this model here. Remember, we had the equation 6 divided by 2/10. What does this model represent? What are the green ones? What do they represent? What did you talk about at your group? Yeah. They are tenths, but in the problem,
They represent 2/10 have 6 divided out by 6, so the other 2/10 they're each are divided out by 6.
okay, so they're showing how many tenths are in what, but what are the green ones from the problem? These green sticks represent what from the problem, Cole?
10. They represent how many 6s? So 6. 1, 2, 3, 4, 5, 6. That's your total of. That's your 6.
Okay, so they're my whole,
Yes.
right? But in the problem, what was the 6? 6 what? Feet. Are you with me? So I have my 6 feet of ribbon, and now I'm trying to find out how many what?
How many 2/10s can fit into
How many
6?
2/10s will fit into 6? Right? Does this show us how many will fit into 6?
Yes, kind of.
Does it? Let's look at another model and see what you think about how it's like this one, okay? And see if it shows us how many 2/10s fit into 6. Are you ready?
Yeah.
They use the chips. I'm going to freeze that. So let's take a look at that. Did it freeze or no? Yes, here we go. All right, so those are the 1, 1, 2, 3, 4, 5, 6. You see the ones there? And then the 2/10s. Are y'all with me? So think about that last model that we just looked at and this one. And I want you to think about, I'm confused. Remember, we were trying to figure out how many groups of 2/10s went into 6 holes. What is happening here? What is this? What does that mean? What are they thinking? And what in the world? Why are they doing 6 times 5 equals 30?